Example 4. Which of the statements are true about the function y equals f of x graph below? Which are false? So A, find the limit, okay, or I should say, is the limit as x approaches -1 from the right, remember the right because the positive symbol right there of our function f of x is 1. So the right side, let's talk about this right here, okay, here's -1. Remember, we have to look at where x is. And we're standing coming from the right, meaning that we have to stand on the right side, okay? And we're walking towards x being -1, and it's y approaching that value, and y it's approaching 1. So this is definitely true. B, find the limit of f of x as x approaches 2. Is it DNE? Now, DNE means does not exist, okay? So if you're not listening, then I know that you are not listening when you asked me what DNE is. So true or false? It's the limit as x approaches 2 of f of x does not exist. So we are gonna go look. Let's find where x at 2. Here is x equals to 2. And remember, the limit does not exist if the left side and the right side are not equal. So let's start with the right-hand limit. Right-hand limit, students, that means you're standing on the right side and approaching 2, okay, on x. So the limit as x approaches 2 from the right, the y value is approaching. Remember, even though there's a hole right there, that means in algebra value, that location does not exist. But that doesn't necessarily mean that the limit does not exist, okay? The limit is what y is approaching. So y is approaching 1 the entire time. Now the limit as x approaches 2 from the left. Remember, left means we're standing on the left side and approaching that x location. And this x location again is 2. Y value is still at the same place, which is at 1. So y is 1, it's approaching 1 for right and left. Well, right hand and left hand limit, they are exactly the same. Therefore, this should exist. So the answer to this would be false. 3, I'm going to erase before I start 3. 3 says, C, true or false, the limit as x approaches 2 of this function is 2. Well, clearly we just wrote down that the limit from the right side, okay, it's 1, and the left side mean again, standing on the left side, going towards that location is 1. So that's also false. What is DNE? I hope you're listening. Okay, E, true or false, find the limit as x approaches 1 from the right, okay, is it 1? So true or false, f of x, the limit as x approaches 1 from the right of our function f of x is 1. So remember, let's go find where x of 1 is at, okay, x is 1's right here. Right side, students, meaning you're standing on the right, okay, we're getting closer, and that is definitely true. Okay, the y is 1, we're approaching 1. True or false on f, the limit as x approaches 1 is not going to exist. That means the right and left must be exactly the same. Well, we already have the right side being 1. Let's test out to see what the left-hand limit is, okay? The limit as x approaches 1 from the left, if it's 1, then it will exist, okay? But if it's anything but 1, then it doesn't exist. So left-hand limit, meaning that you're standing on the left. Remember, you have to follow the curve. If it's flat, then you go flat. If it's curvature, then you go to curvature. You're creeping towards x of 1. Well, as we are moving closer and closer to 1 on x, the y value is actually creeping, aka approaching 2. So left hand is 2, right hand is 1, so that means they are not equal, therefore it does not exist. Oh, you know what? I forgot D because I didn't pinch it all the way in. D, true or false, the limit as x approaches 1 of f of x is 2, okay? Well, that brings us to the question, is it 2? Not really, okay? For this to exist, students, the right and left must be exactly the same. And right and left are currently different, so this is false. G, true or false? The limit as x approaches 0 from the right is exactly the same as x approaches 0 from the left. So let's erase what I have marked, and then let's go to x being 0. Here is x being 0, okay? That means right-hand limit as we are creeping towards x being 0. Ooh, y is 0. Left-hand limit, standing on the left side, getting closer, closer, closer to 0. It's also 0. So right and left, they're both 0, therefore true. H. Let's make sure we know how to read this. The limit as x approaches c of this function exists at every c value in this, okay? So that means c is going to be non-inclusive on both endpoints here from -1 to 1. So it could be -0.9, -0.8, right? 0.99999. That's what it means by in the middle of -1 and 1 non-inclusive. Now remember, for the limit to exist, the right and left must be exactly the same. So let's go and look where c is from -1 to 1. So here's -1. Remember, non-including the endpoint. Here's 1. Okay. Don't look at the endpoints. Is it continuous the entire way? By definition, if it's continuous between -1 and 1, then that means the limit will exist. Okay, so true. But that's not to say, I want to repeat this, that's not to say that if it's not continuous, that it doesn't exist, okay? But if it's continuous, it guaranteed to exist. Now, I says, the limit, true or false, as x approaches c of our function f of x exists at every c. C is a value in the middle of 1 and 3. So let's go look at 1, and let's go look at 3. Some of you might say, well, there's a problem. There's a hole right here. The limit may not exist. That's not true, okay? This also is true. The limit does not necessarily mean it has to be continuous, okay? But if there's a hole, we just have to make sure that the right side and the left side towards that hole, that non-continuous piece, is the same. And as we both are creeping towards an x value of 2, both y is 1. So therefore, the limit is okay. It does exist at 2, at x equals to 2. So this is also true. Let me pinch it in to see if I didn't miss anything else.